Like programming languages have their own words and syntax and whatnot, object orientation needs some communication path. In this case, it's going to be pictures, diagrams that help us describe these complicated concepts. And the main, probably the only, notation for that these days is something called the Unified Modeling Language. UML comes from these three gentlemen you see there, Ivar Jakobsen, James Rumbaugh, and Grady Booch. So these were three computer scientists who each had their own set of notation. They brought them together and created this idea of this unified modeling language, which is why there's a few different options in UML and there's a few different ways, but it really has been a great way of taking these complicated ideas and making them very visual, very easy to see. And so if we look at a class diagram, we've seen these already, we can see this box and instantly recognize a class, or at least you'll learn to with practice. And so the top, it's called the compartment of this box, is the name of the class. And then this middle compartment has the attributes of the class, and the bottom compartment has its operations. So what is it? What does it know? What does it do, if you will? And then we can actually add in the idea of it communicating with other objects by showing lines between them. So this is the example we saw previously, but now we'll talk about this syntax. The box itself shows a class. If you ever see a box with nothing but a name inside of it, it's just showing the name of the class. Or I can show one or two or all three of these compartments. So there's actually a fourth compartment you could add for events as well. So the line between these is called an association. It's some relationship between two classes. We'll learn later on, there's this differentiation between classes and objects. We're actually going to talk about that in a second. But an association is between the structure that is a class, and a link is between two objects itself. So what do I mean by class versus object? Well, classes are kind of like a cookie cutter. They define the shape of an object, if you will, where objects are like the cookies. I don't build a cookie cutter to build one cookie. It's a pattern, it's a template, and I build a bunch of cookies because everybody wants a cookie, right? And so each cookie takes on the basic shape of its cookie cutter, the attributes, the methods, but it has its own custom as well. The class doesn't define the decorations, for example, on the cookie. You could put blue frosting or pink frosting or yellow frosting or polka dot frosting or draw a picture on it or just leave it plain. That is the idea of an object. You have this structure, but I can add values to those attributes. And then they all behave the same except being customized by their attributes. That's, like a cookie. I know the shape of it, but I can have different flavored cookies, like chocolate chip cookies or butterscotch cookies or any other flavor I want of my cookie. So the objects are different than the class, but at the same time, they are based upon and build from that class. So a class has this idea called membership. So class members are attributes and operations slash methods. Again, an operation is at a class level the definition of a behavior of what an object will give you. The method is the actual code, the implementation of that method. So conceptually, they're slightly different. There's what you can do and how you do it, but for pragmatic purposes, they're the same thing. I mean, you've probably heard them called methods in Java or C. Maybe your whole career of coding so far. It's the same difference right there. So it's important at object oriented level. It's not terribly important when we get to code. But the idea of membership is important because every object has all of the members from the class it's built from. Every game board object, and there could be many of them, many games going on at the same time. Think of a checkers tournament. There could be hundreds of people playing at the same time. Every game board has a board. They know what player's turn it is, and they can make moves. So this is important because objects allow you to hide information, if you will. So think of your wallet, your purse, whatever you might have there. You hide most of the information that's in that wallet, but other people can access it. So you don't give people access to your wallet willy-nilly. They can't just take your money and access your credit card numbers and pull out your driver's license, but they can ask you to pay them. And you might choose to take out money and give it to them. You might choose to use a credit card and give them. So when I say pay, hey, give me money, you have your own choice of what that means and how that gets done. And that could be different in different objects. Some of you might pay in, dollars, and some of you might pay in, you know, uh, yen, or you might pay in credit cards, or you might pay on Venmo. All of them are legit. All of them are helpful, but they are choices you make inside the object. And objects do this itself. For the most part, attributes are private. And for the most part, operations are public, but that's not universally so. I can have public attributes and I can have private methods, things that I do for my own purpose that other people can't be out there. So on top of UML, I could add in this notion of visibility, which says what things can you access and what things can't you access. And so the minus sign says it's private. That's only for internal use by the objects. The plus sign says it's public. It's things that other people can access and call and use, or however they want to. And so this notion gives us a lot of power to basically take in data using methods, using operations, and store it whatever makes the most sense. So, for example, you could, I could tell you, hey, it's 2 o'clock, and it might be in whatever time zone you're in, but I might live in a different time zone, and I've done the translation to Universal Time Coordinate, or something like that internally, so I can store that time differently in my head than maybe what I communicate with you. So that way you can, plan accordingly. Similarly, any functionality could be like that. Now, object tracking is also a really important thing to remember. And so, um, so associations between objects is not just simply a for a few minutes sort of relationships. It's something that I'm going to keep track of, quote unquote, permanently. More specifically, it's a role that helps define who I am. So, for example, most humans have some sort of parents or guardian or somebody that fits in that role. Not everybody, though, right? Some people have had parents pass away, or some people never knew their parents. It doesn't mean that humans don't have that role. We basically have to have some sort of biological mom and dad to exist. So associations say these are things that an object would typically keep track of, but it doesn't mean that they must exist or must be valid or anything like that. And more importantly, they're not necessarily things that are a bit more ephemeral. They're not things that kind of come and go. They're things that you're going to keep track of and remember for a long time. So think of it this way. If we go back to our order, the cashier might be really, really important for the order. But the person who might be bagging your groceries, or the person who's bussing your tables, they may not be something we need to keep track of, right? So, for example, if I go back to the restaurant and I want to give a tip, the tip might go to the cashier, but the tip might not go to whoever the busboy was that night. It's unfortunate, but that used to be true, and maybe less so these days. Um, but that's part of what the model is saying. So, in your life, you probably have the notion of a person who delivers your mail, but you might not keep track of that person, right? Maybe you do, maybe you don't, right? Maybe that person switches regularly, but you keep track of them, whoever your current post person is. Or maybe you don't know at all. It's just somebody walks up, they deliver a package, and you go from there. So if there's somebody who comes to your house every day, you might know them, but the random, delivery from Amazon, you might not keep track of that person. So it depends, as so much does in objects, on whether you need that information, whether you're going to call up that person. I might call my post office person and say, hey, I didn't see my mail today, but I'm not going to call the random UPS driver and say, hey, where's my package? Because anybody could have been delivering that. So when we have an important association, we track that using these lines in UML. The line between two objects is the association. And then I can put a name, like in this case, cashier, on that line to show what role the employee plays to the order. They're the cashier, right? They're the waiter. They're the whatever that role might be. So UML associations basically is a line between two classes, but no arrows. There's no arrows in UML for associations typically. There's a few things that kind of have some special symbols, but generally speaking, no arrows. Um, if you have no labels on either side, it implies that each class might keep track of the other. I don't really know. So that's why I use labels to say this is the role you're playing for the class at the other end of the transaction. So if you think of the previous diagram we were looking at, it's the employee is not thinking of themselves as a cashier. They're just an employee. They could be a manager or a fry cook or anything on different days. But the order is considering that employee to be the cashier, right? And so that association can also have some sort of numeracy to it. I can keep track of one of a thing or not put a number at all and assume to be one. Or I can keep track of two of a thing or 10 of a thing or some range. I could have one or not, or I can have 2 to 4 of a thing. Or it can be any number. I put a star inside of there. It might be zero, might be one, might be 1,000. It's a list of things, if you will, that's showing there. And so that is some foundations of UML. It gets a little bit deeper into object-oriented thinking as well, because that's what notations do. They make you think more deeply about what they're documenting. But by learning UML, it's going to allow you to both understand it better and communicate your understanding better. So by practicing drawing UML as well, it's going to help others see your capabilities in object orientation, not just for school, but also show that you're a professional who really understands your field as you go out to the workplace as well.